Hey guys, you again with Committed. Don't forget to register in Slido. Scan QR code from your mobile so you will be able to ask a questions. Also, please like a questions you are interesting James to ask. Today we are a little bit limited with the time. We have only 1 hour, so we will spend approximately 45 minutes for an interview and 15 minutes for the questions James will answer. So please meet ex-Google, former Microsoft visionary James Whittaker. Hi, James.
Hey.
So
Hey
my
guys, how y'all
questions,
doing?
good, and you?
Everything's good. Sunny Seattle.
Yes. So my first question is following. You are so long in the industry. How industry changed over time? How is it was
Yeah,
20 years
very
ago
polite
in
way of
testing?
very polite way of noticing my gray hair. Thanks for that. Yeah, I have been in testing for a long time. I started when I was a graduate student at the University of Tennessee, uh, many years ago, and it was kind of cathartic. It really cemented my place in the industry because I didn't fit in. There everybody was learning. It was so new. PCs were new. Most of us programmed on mainframes or SunSpark stations, and it was just this dynamic, wonderful time in the industry. I feel sorry for people who are too young to have remembered that decade. Because testing, once I started getting into testing, I sort of found my flow in the industry, and it's difficult to overstate how important testing was back in the day. Quality, I mean, software was shit. It was terrible. Everybody's software was terrible because every machine it ran on was different. And so you could build this app and do all this testing, and then it wouldn't work on any of your users' machines because there was just simply no real standards in the industry. And so quality was everybody's biggest problem. And they took testing and testers very seriously because of that. I mean, think about it. This is the time when people would ship uh, software on discs. Later in the decade, it became CDs, but it was still the same thing. You had to take all that development activity, you had to cram it on this disc, and then ship it out to your customers. You had no idea who these people were. You didn't know they didn't log on. They just bought your shit at Best Buy or something like that. And uh, that we had this word recall class bugs to kind of describe this situation, because if that disc, those CDs have a bunch of bugs on them, you've got to do it all over again, right? You can't fix the bugs in place. And so this industry was just stunning. I mean, academia was really involved because we didn't know how to quantify software quality. We didn't know how to measure software quality. We didn't know what to do with bugs. There was all these different theories about how to find them, like fault injection, seed a bunch of bugs in, test the crap out of it, see how many seeded bugs you found versus how many non-seeded bugs you found, and use some pretty good higher level math to kind of figure out your reliability. It was a big deal, and we were taken really seriously. It was an absolute rush, and the amount of intellectual horsepower, in academia that was put toward this. People like John Musa, Elaine Whittaker. I'd like to put myself in there. I was studying for a PhD and then eventually got a PhD and studied this stuff full time. Lots of papers. Jeff Voas was another big name. A lot of these names I haven't thought about in a long time, but uh, there is this real intellectual component to software testing that was just out of this world cool. I remember this one time I was speaking at, there's an old conference called Quality Week. I don't know how many of you all I remember. It was in San Francisco every year. And then there was the Star Conference that kind of popped up in Orlando to compete with it. But Quality Week was the major event. And all the speakers on the circuit, we all cut our teeth there. I got on the speaking circuit there by winning best presentation. and then catapulting me into a keynote role. And I remember giving a talk at Quality Week San Francisco. It must have been, I had my daughter with me, so it must have been like 1994 or 5 or something like that. And after the talk, everybody just sort of crowded the stage, and asked me questions like, "What about this?" and "What about this?" They were kind of enamored with my stage style, and I remember the crowd just sort of parted, and this dude walks through, and he kind of had this sort of hip vibe, his hair was a little bit long, and he was sort of half buttoned up. This is when we were still deciding whether or not to wear suits to work, sort of half buttoned up and half just kind of chill. And I didn't know who he was because, I didn't know anybody in the industry. I was kind of academic. And but the respect they showed for this dude was pretty outrageous. His name was Roger Sherman. He was the Microsoft's first director of test. And, he had thousands of Microsoft testers that reported to him. And he just sort of parted the crowd, handed me his card, and like 7 p.m. we're having this big party tonight. And, it was just the kind of party you'd see on in Hollywood or something, big and catered and all this free alcohol. And I don't think they do that anymore. The Microsofts and Googles of the world aren't coming to conferences and splashing that kind of cash. And I mean, this was back in the days before, we were so aware of just how white and male we were. I mean, they even had like dancers and shit, and people coming around bringing you drinks. This shit doesn't happen in software testing anymore. And so I wrote it out as a professor, as a consultant, Microsoft and IBM, and wrote a bunch of papers and gave a bunch of talks. And then by the end of the decade, things really got fun. And I'm not sure software testing will ever have this kind of Y2K moment again, but I got really involved. All of us, the entire industry, got really involved in Y2K. And if you're so young that you don't remember the Millennium Bug or the Y2K bug, you really should curse your youth and understand just how much you missed, because this was the golden age for software testers. Right? There were bounties that people put out on bugs. Bounties. If you found a bug that had to do with date math, I'm not going to tell you what Y2K is. I'm going to make you look it up. Google that shit, or Bing it if you must. But any bug, right? There were like Boeing dudes going into the flight simulators and changing the date to 2000, and all flight simulators crash. And there were dudes in the back room of banks. I say dudes because they were probably all dudes back then, unfortunately. Going to the back room of banks and like taking a couple of test machines and moving the date up to 2000, and all of a sudden all the calculations are just fucked and they can't compute, all those, they have stuff that banks compute, right? Interest rates and all that on loans and things. And so there was this real fear in the industry, and because they called it a bug, technically probably wasn't a bug, but because they called it a bug, all of a sudden software testers were a thing of the 6 o'clock news. I was getting interviewed by newspapers and television, and it's crazy. That was the golden age. They were paying bug bounties of, thousands of dollars for any bug that had to do with date math. And I happened to be a professor at the time and started the world's first curriculum for software testing at a major university. And so, me and my students just sort of tackled this problem in mass and made a lot of money. I remember one of my students, Rahul Chaturvedi, bought a Corvette with the proceeds from our Y2K testing. Students make it as much as teachers. That kind of stuff just doesn't come around so often, and it was a real rush to be in the industry during that time.
So James, it's so exciting to hear that story. I'm really impressed in your experience in Google, Microsoft. So just a little question about the testing is being conducted in Google, Microsoft. So how was it being a testing specialist in Google, Microsoft? What was the test management? What were the processes and challenges you were facing in Microsoft and Google?
Well, I mean, they were different because everything Microsoft did was on the desktop and on the server. Server meaning a Windows machine somewhere in your back room, right? Server farms, and then at Google, everything was in the web and the cloud. And so, but Microsoft was the original company that Microsoft's easy to deride. I deride them myself. They did a lot of bad things. They've done some good things. But man, every software tester on the planet owes a debt of gratitude to Microsoft. In the 90s, they decided that finding bugs was important as writing them. And that they were going to pay software testers the same as they were going to pay software developers. They were going to listen to them. They were going to promote them at the same rate. That might have been the one promise that really didn't come through, that they were promoted at the same rate or at the highest levels of the companies, but it's pretty damn close. And for a support-ish role, right? We didn't create the product. We just took the worst parts of the product out. That's the real goal of software testing is to understand where the seams are, to understand in the app that you're trying to release where the complexity is. That's what we do as software testers. We surface complexity. Don't let anybody define software testing in any other way. That's what it's all about. That's what the test cases are all about, surfacing complexity. That's what we do because we don't really do anything about it, right? The devs do that. So Microsoft had this incredible synergy. I hate that fucking word, and I said it out loud. Synergy between testers and developers and program managers, right? They called it the triad. And Microsoft was a company that gave testers a seat at the table. We all owe a debt of gratitude to them. And then at Google, the web kind of changed things. The web. Wait a minute. One more point about Microsoft. I forgot. One more point about Microsoft. Even though all I said about the debt of gratitude, Microsoft still rewarded test tool developers, far more than they ever rewarded just rank and file software testers who found bugs. We don't really have testers anymore. Microsoft doesn't. He is a royal we. I'm no longer employed by Microsoft, but it was always the test tool developers who got promoted fastest. Microsoft worked the manual testers out of the ecosystem probably by really when the web came around, which gets back to my story that I was telling earlier. The web kind of changed everything. I remember finding. So I mentioned my time at the university. Me and my students would break software. I wrote a book at that time called How to Break Software, and took a lot of joy in finding bugs. It's a rush, or at least it was. And we would just buy a piece of software, install it, find a bunch of bugs in it, and report the bugs to the manufacturers, hoping that they'd be like, of this. And of course, that's where the lawyer got involved. I would charge $25,000, and this is late '90s amount of money. 25 grand you pay to the university to have my software testing class break your shit. And I mean, we got software from all over. NASA was one of our customers, Lockheed Martin and Harris and all those government contractors, Microsoft, Ericsson, Cisco, Google. We had all these sponsors that would just kind of throw 25 grand at us. And we got really good at breaking software. And I remember when the web came along, it sort of changed the game because people took it a lot less seriously, because the web allows you to update the software in place, right? You don't have to print all those CDs and ship them. You don't have to do all the reinstall. You don't have to reinforce your customers, right? You just have to ship it, and then the user presses F5 to refresh their browser, and ta-da, you've got a new version. So the web cheapened software testing in two ways. First of all, it made automation a hell of a lot easier. This is where WebDriver came around, right? And because it was easier to automate, it was easier to take, manual test case and turn it into a bunch of clicks and gets and posts and things like that. And so it made testing much more automated, which required fewer people, much more easily automated, I should say. And the second thing it did is it made bugs a lot easier to fix. And so, and that took the value away from testing. I don't think Bill Gates ever said this, but everybody was ascribing it to Bill Gates that I can fire all my testers because my users are my testers, something like that, right? And in a way, it was true. I don't think Bill said that, by the way. And the users did become the testers because it was easy to find and report a bug and have that bug fixed immediately in the copy of the software that you're using. All you had to do is refresh your browser. And so that was the time I realized that, I'd spent a decade or so, maybe a decade and a half, perfecting this skill of software testing, and all of a sudden it was F5'd out of existence. And that's when I switched to security testing. One of the things, if you're a young software professional just starting out, not sure I would recommend software testing as a full-time discipline. And if so, find a part of software testing that's people take seriously. And I mean, if you enjoy it, you enjoy it. If you don't care about making a lot of money, or you don't care about, most of the rest of the industry, fine, is sit in your bubble and test your software. But I switched to security because I recognized, I gave up a decade and a half of skill and experience in software testing and switched to security, because that's the thing in the 2000s that everybody was talking about. In the 1990s, it was all about quality. In the 2000s, it switched to security. And so I switched to security. I'd written How to Break Software. I wrote How to Break Software Security. I wrote How to Break Web Security, and followed that trend. And now I think if I was going to go into it, I'm fast forwarding a little bit. Now, if I think I was going to go into it, I would probably go into, something that has to do with testing artificial intelligence. You see this particularly with Tesla, the autopilot failing and getting stuck and crashing. And these are bugs that software testing as an industry really needs to focus on, because every time we've done that, in the 90s when we focused on functional testing, in the 2000s when we focused on security testing, we made a ton of progress. And testing it, and I'm not saying using AI to do testing, that's fine. Jason Arbon does a great freaking job with that. I'm talking about testing the output of an AI, testing the output of a machine learning algorithm. This is going to be the future. But back to Google. So I had given up software testing in the 2000s and then kind of got back into it when I was recruited away from Microsoft and joined Google in 2000, whenever that was, 7, 8, whatever. And Google was definitely the place to test software. The contrast between Google and Microsoft couldn't have been bigger, even though the Google testing process was kind of created by an ex-Microsoftie, my former boss, Pat Copeland, who is now at Amazon. He came from Bing and went to Google and kind of created their whole engineering productivity. They didn't call it testing at Google. They called it engineering productivity, with the idea is that this is not about finding bugs. This is about energizing developers. This is about making developers better. Because every software tester at some point is a tool developer. We've all done it. If you can code and you're a software tester, you've created a tool to do software testing. And so we sort of did that on a mass scale at Google. A lot of that cloud testing infrastructure, a lot of the cloud infrastructure itself was created by our group. So I never really felt like a tester at Google. My title had nothing to do with testing. Nobody was called a tester, and we were mainly in charge of making developers productive, and in doing so, making our products better. And that was the real catharsis for me, was that the testers don't make software better. Testers, expose complexity so that developers can make software better. And I think that's eventually what led to Larry Page when he took over as CEO in 2011. Just destroyed the testing, engineering productivity discipline in general, and gave it back to the product team. So our group was completely split up, and we drew straws about what we'd work on. I got recruited into Google Plus, of all places, and it was a premature end to my Google career, because let's face it, Google Plus blew chunks. That's my pause to allow you to ask another question.
Okay, your book, How Google Tests Software, created a lot of rumors that testing will die, because in Google, and you told it now, there wasn't testers, there were developers in test. Now we see many companies that get rid of the testers, like Microsoft, Boeing, and many others. So do you think that software testing is a discipline that won't exist in the future? Or how do you see software testing in the future?
I think it's mostly already dead. So this isn't my original opinion. Actually, I got this fed to me by Alberto Savoia, who on Twitter is at Pretotyping. And he gave a talk at GTAC, Google Test Automation Conference, 2011-ish, 12 maybe, I don't know. And it was titled "Test is Dead," and he took a while to convince me. He kept telling me it's unnecessary, and I started really thinking about, is he right? Because 2011, if I compare quality of software in 2011 to the quality of software in even 2001 or 1991, holy shit, there was a big difference. I mean, software got good in the 2010s, or even in the late 2000s. Software just got a lot better. It was a lot harder to find bugs. And so I thought, well, isn't that a success? Can we as software testers claim, all right, we solved this fucking problem, now we'll go off and we'll do something else. And I got to thinking about, well, why is software better in 2011 than it was in 2001 even? And it wasn't because of testing. It was because of the cloud, right? The cloud just made development easier. It took a whole bunch of things that developers can fuck up, and it made them not fuck upable, right? Or at least a lot harder to fuck up. And so the cloud, right? That's one of the things. And then DevOps, that's another thing. The fact that all of a sudden our computers were all the same, right? If you wrote an app for one iPhone, it's going to run on every iPhone, and we have to worry about all that client side variability that we used to have to worry about. And I started ticking off the things that are really the reason that software quality has gotten better. And I gave a talk at Star in Star West 2011. It's on YouTube somewhere. You can look it up. I don't remember the name of the talk. And I went through these, 6 or 7 or 8 things, the reasons why software quality was really better, and software testing wasn't one of them. And so I finally had to agree with Alberto. You're right. Testing, as we know it, is dead. It's simply between the automation that we have written over the last few years and just the infrastructure and environment changing underneath us to support better software. We really don't need all that manual testing anymore. So whenever I hear companies that say, "Oh, you want to hire a bunch of manual testers," I'm always a little skeptical of those companies. Like, what was it about 2005 that appeals to you so much that you've just stayed there? It's 2020 now, and most of these issues that software testers used to wrangle with have gone away. And so there's the worst I can say. Now let me temper it a little bit for my software testing audience. There are still a bunch of opportunities in software testing, but it's not the shit that we've been talking about. It's not these silly little certifications that I don't believe in. It's not the reading books by. I'm sorry, I don't believe certifications. They don't make you good. It's like a college degree doesn't make you good either. The certification doesn't. It's not worth the paper it's written on. The best people I've ever worked with don't have these certifications. No one at Google had these certifications. No one at Microsoft bothered with these certifications. It's I don't see the purpose. And if that doesn't get me invited back, that's okay. I will survive.
Okay.
So I think that software testing is changing fundamentally, and we have to start looking for the real problems. And to me, the real problems are this AI, right? Can we as testers, so the testing mind, right? The way we think about a problem is valuable. It's really valuable. It was valuable in the 90s because we thought about breaking software. The developers thought about writing software, and it was a different mindset, and we were able to contribute. And the same way with security in the 2000s, the way I thought about security was different than the way people thought about security. Like my colleague, Michael Howard, we were both at Microsoft together. He was a guy that talked about developing security. I talked about finding security holes, and we eventually coalesced in the middle. Now we have to start thinking about data, because data is the center of the world now. Right? Data is the new oil. I may or may not have been the first person to coin that. I don't care, but it is. Data is extremely valuable. And right now, data is being used to train AI in ways that make it biased, right? Facial recognition could only recognize 2 of the 3 of you all on stage. Well, hello, Clarence. Want to say hi to everyone? This is Clarence. Clarence
hi.
Because
Hey.
it's Clarence's breakfast time. And you're not going to get breakfast until this is over.
You gotta feed him.
So, no, he'll be fine. He'll live. He might shit on my couch, but that wouldn't have been the first time. So, this is a testing problem, and that's what I think we have to stop doing the stuff that we've been doing. Anybody can test software. Testing data is hard. Extracting bias profiles from data is hard. Understanding what data is training the AI and what are the potential pitfalls of that. That's that testing mindset that we need to resurrect. It's not really. There's a better name for it. Stop with the word tester. That's not what we're doing. But this whole concept of bias in data, this whole concept of incomplete data set, this risk mitigation that we need to do with AI that's being developed by people who don't understand it. Right? AI is different. AI is not programmed. AI is trained. This is fundamentally important. We don't code AI, right? Somebody at Tesla didn't write the code like if you see a stop sign and if there are 3 other stop signs, right, 4-way stop, then proceed. Nobody wrote that fucking code, right? You don't program a car to drive. You train a car to drive, just like you don't program your child when you're teaching your child to drive a car. Or your teenager, child, I don't give a shit, is driving somewhere off the road. You train your son or your daughter to drive a car, and they learn over time. And this concept isn't being looked at anywhere near deep enough by people who have a testing mindset. So stop celebrating testing and instead start celebrating your testing mindset, because it's way more important than you think. And you need to start applying it to problems that the world really needs a solution for.
James, thank you for your vision. We also would like to ask our audience about what actually they think about the future of testing. Also, please show the quiz results to the James. Guys, join Slido, pick up your phone and vote.
through. This determination that manual testing will rise up again, I don't agree with. I think the manual testing mindset will rise up again, but only if you learn to apply it to modern software. And modern software isn't programmed. Modern software is trained, and there is no more fundamentally important concept to take into the next few years of your career than that. We are no longer writing software. We are training algorithms to do shit. And it's a fundamentally different mindset. And I don't see it talked about anywhere near enough in the testing literature. I can imagine what we'd have done with this in the 90s. We would have celebrated the complexity of this problem and dug into it, like and solved it. Just like we solved the security testing problem, we solved the functionality testing problem. Right now, I mean, solved. Right, they're still writing new bugs, but we know what to do when we're doing functionality testing. We don't know what to do when we're qualifying a data set for training. We don't know what we're doing when we try to quantify the limits of the AI that's trained on a particular data set. We don't know how to pull out what's missing in a data set. We don't know how to correct it. These are all really good problems, and you want to make a name for yourself. Study
James,
this shit and get
do
good
you
at
see
it.
voting results?
Do I see what?
Voting results in Slido.
There is a voting results. You can see it on Slido on the main screen. People are voting regarding the future of testing.
Yeah. I see it. Test automation will play a main role. The number one set here, and maybe I have to scroll. I'll do it on my phone.
The most interesting part is that manual testing will raise up again. A lot of people vote for that.
Again.
Well, I mean,
Again.
you can wish it to happen. I am hoping that liberalism rises up again in the face of all this deplorable nationalism that is causing us to do stupid things in this country. I can wish it all I want, but I'm telling you, you've got to make this happen. No one's hiring manual testing that I know of. Every startup in Silicon Valley does. Their developers are their testers, their manual testers, as it should be. Because there's a bunch of shit that goes on in the cloud that requires expertise. There's one thing to find a bug, and there's another thing to know what's happening. Here's my challenge to manual testers. If you can find a bug, I don't care. If you can find a bug and understanding, what that bug is, what was the most likely cause of it in the cloud, right? What part of the chain of events is the fault occurring, and then be able to fix it? That's a valuable skill. But if your only skill is pointing out, hey, this is broken, no one's going to listen to you. Microsoft eliminated the testing discipline. Google eliminated the testing discipline. No company I know of that in Silicon Valley, from small to medium to large, does this anymore. And if they do, they contract it out, and they don't take it very seriously. So, why would you want to do that? Software testing is probably never going to die. Nothing ever dies. Right? There's still IBM mainframes out there. There's people who need to write COBOL. The U.S. government's still hiring COBOL programmers. Nothing ever really dies. But you ask yourself, are you willing to work on something that people don't really take all that serious? If so, that's great, right? Go, if your side hustle, your hobby, your nightlife, your sex life, whatever it is, if that's the most important thing to you, and the job is just about making enough money to support all that other shit, then go do it. Don't worry about what I say. Live your life. But if you want eudaimonia is ancient Roman concept of fulfillment, of doing something that matters, right? Then that's going to require you to think a little more broadly.
Thanks.
Who else do you want me to piss off?
Oh, okay. You are talking a lot about the future. And what do you think? What will be the next big thing? I'm talking about we had personal computers, we had web, now we have mobile phone. What will be the next?
It's going to be IoT. It's going to be smart infrastructure. So my prediction is that, and we did, right? So actually, it goes back further than that. We used to have mainframes that solved big business problems, automation of business processes, and we did that for the entirety of the 80s. In the 90s, it was the PC was the hardware that won, and it was personal productivity that was the focus of the problem. And then in the 2000s, it's interesting that these are on 10-year cycles. In the 2000s, the hardware didn't change much, but it began to disappear, behind server walls. We had the web, and the problems that we solved were, e-commerce, social, connecting people. And then we had mobile in the 2010s, right? The iPhone was 2007, but it really took over the world in 2012. 2010s were all about mobile experiences, and now I think that machines, we may or may not carry these machines for the rest of our lives, but the machines are going to go somewhere. The computing power has always migrated somewhere else, and I think it's going to migrate into our environment. Smart infrastructure, right? Buildings that are capable of processing all the data within those buildings and doing things in place, right? A building that recognizes, oh, I'm a restaurant, or a building that recognizes, oh, I'm a movie theater, and collecting the apps that correspond to those sorts of things. So that's the problem I'm working on now in my capacity at Biscuit Labs, is building a computer that allows you to reduce physical spaces and physical structures to data. So it's going to be IoT, and most of the interesting algorithms require some machine learning and AI.
Okay, what about augmented reality?
Now, augmented reality is more of the UI for that, right? It's a way of expressing the output of that AI and the output of all of those devices. So I see augmented reality as the new UI, the ability to do gestures in space, the ability to see something and not necessarily have to be staring at a screen in order to see it. So augmented reality is definitely part of this future, but it's not the future. The future is IoT. The computing horsepower is going to be fixed in place in physical structures, and augmented reality is going to be one way to see into it. Much like the graphical user interface was the UI for PCs, the augmented reality will be the UI for IoT.
So at some point, James, you think that IoT will be a piece of a human body at some point, because people are getting lazy more and more, and at some point we won't be like touching some buttons or controls. We won't just something to control by our own mind. So how do you think?
That's Elon Musk again. I don't know how many times I get to mention him, but I think I'm going to stop after this. But he's convinced that that you can read brain waves extracranially, right, outside the brain, and be able to control things, control the physical environment, which requires computers in the physical environment. This is another reason that I think that IoT in physical spaces is going to be big, is going to be the next platform, if you will. And so, how to control those computers is a question, right? The gestures and voice is what we use to control them today in 2020. Augmented reality is going to put another spin on that. It's going to give us a much richer set of gestures and a better way of consuming the output of those computers. And then the next step would be controlling them perhaps with our mind. How close that technology is, I don't know. But they've done some things that are would have thought impossible 10 years ago. And that's the thing about technology. When you hear this stuff and you say, nah, it's not going to happen. Well, that stuff has been happening for 30 or 40 years. the mainframe people said, come on, PCs are just a dream. They're little toys. They're not going to work. And then they worked. And, the PC people said, the web is, Amazon is a little toy. There's only a few apps you can use. And of course, the .com bust in 2001, 2001 was proof to the PC people that the web doesn't really work. And then that shit worked. And then, of course, I was at Google when the mobile phone, when iPhone shipped, and we're like, the browser is a much better experience for all this stuff, right? That little bitty screen. That shit worked, and now IoT is working, and that stuff seems like science fiction, but I wouldn't doubt the tech industry. We're pretty good at implementing the impossible.
So I'm wondering, James, it's very interesting to ask you because you just said that many companies are removing completely the testing role, testing departments. I wonder, maybe that's because like a testing role is one of the least appreciated roles in IT companies, whatever. But why is this? How do you think?
Because
why?
It's a value proposition. It's a value proposition, right? Back in the 90s, the value proposition for testers was better. You could not test in the 90s if you wanted to, but at the cost of having to recall all those disks and reship all those disks out to a bunch of customers that you just pissed off, right? It's one thing to have a bug in a web app that you can fix remotely and then F5 refresh your browser and it's fixed. It's another thing to have to wait for the US fucking mail to deliver your apps for you, or to go to Best Buy and wait for them to restock the CDs. So the value proposition for testers was clear. If we don't have them, we make a lot less money. And so now the value proposition just isn't as strong. And when my career superpowers, when I talk about career advice, if you invite me back, we could do a career session. It's a value proposition, and people are like, oh, why am I getting laid off? It's like you're working on the wrong value proposition. Your company doesn't value the work that you do. People whose work is valued don't usually get laid off. They don't get fired. They get promoted a lot. And so you train yourself to focus on that value proposition. And so what's the value proposition for some manual testing right now? It's clear that the industry doesn't value it. If they valued it, they'd still have testers on staff that they paid benefits to and that they promoted and that they nurtured their career, but they're not. They're outsourcing it because the value isn't high enough to do it in-house. And so that's your challenge. That's everybody's challenge. And sorry, it's still coffee time here on the West Coast, and I make really good coffee, so gotta sip occasionally.
Yeah, we'll all see you enjoy it.
That's the value. It was, if it was not so late, it would be beer. But that's the value proposition. And come on, look at yourself in the mirror and ask yourself these questions. What is the value proposition of the work that I do? And if you don't like the answer to that, then change the work that you do. I'm telling you that testing isn't important. I'm not telling you that testing skills aren't important. And there's a big difference in that. Use your skills to do something else.
Okay, so you have mentioned today several times that now mindset is changing, and to come to the future, to the artificial intelligence testing, we have to change our mindset, and mindset now becomes important. So, what is this mindset? What it should include? How do you see this new mindset in this new artificial intelligence world?
Well, the mindset changes in understanding, the moving parts of all this, and understanding what is valued by people. Software testing is a set of skills that on its own has decreased in importance over time. Software testing skills all by themselves were really important in the 90s, and you can make a career off of just that. Less important in the 2000s, even less important in the 2010s, and now to the point where there's a lot of other things in the industry that you need to understand, a lot of moving parts that happen in the cloud, a lot of moving parts that happen on the client. The more you understand those technologies and can do those technologies, I don't understand this mindset that manual testing is that the people clinging to it so much. You work in technology. The ability to break software and the ability to write software, the same set of neurons firing when you do it. So become a better coder, become really immersed in the underlying technology that you're implementing on. Every time you find a bug, understand its fix and what caused it, and tie it more closely into the software itself. It used to be that we talked about the independence of testing in the 90s. We don't want, we call them black box testers, right? We don't want them to know about the internal implementation because it might bias them toward, one way of testing, and that might not be the right way of testing. But that doesn't hold water anymore. The more you understand about how the cloud works, Azure versus AWS, and the libraries that are used and the containers that are used and the frameworks that are involved in it, is going to make you a better tester. You need to be just as expert at these processes as the people who wrote the software in the first place. And so there's a lot of other skills besides just testing, and I think calling it just testing cheapens it and makes you less valuable. I could have gotten up here and given you the talk that you wanted to hear and made you all feel good like others do, but I'd rather make you successful than happy.
James, thank you. Unfortunately, we have run out of time for the interview, so could you please have a look in the questions on the questions in the chat?
All right, let's see here. Just in time for it to changing technologies and trends in the industry. I think I talked about that, right? The focus now should be data. The world is data, and the better you understand, right? Go through this exercise. I talked about that 4-way stop. If you're in Europe, you can do a roundabout if you'd like, and in your head, go through that 4-way stop, drive around that roundabout, and understand the decisions that you're making as a driver and how you would figure out how to train an algorithm to do that. We've been with Biscuit. We have this device that goes into a structure and counts the number of people in that structure. And this is a lot harder than it sounds like, right? One we get is a radio signal from your phone. And so we detect the radio signal and say, oh, one person is in the room because we detected a cell phone. But is it, right? Now there's 3 signals, but it could be one person with a watch, a laptop, and a phone, and we're detecting all 3. So that's not a good enough signal to count the number of people in a room. The second is motion. Is there something moving in the room? That could be a person, right? And well, how many people and how do we distinguish between pets and humans moving in a room if we want to just count the humans? And how do we know that movement wasn't like outside of a window or something like that? So that's another signal. And another one would be the microphone. We can hear people talking. But are they people in the room? Or are they people on the television? Or are they people outside the room in the hallway? Right? So this is the types of problems that we solve today. This is data. So we have 3 different data streams. We have the radio connections that our device is seeing. We have the motion data that our device is seeing. And we have the noise, the sound pressure that our device is hearing. How do we use that data set to count the number of people in the room? So this is machine learning. This is data labeling. You take a data set and say, okay, with this data set, we had 8 people in the room. And with this other data set, we had 18 people in the room. And with this other data set, we had 28 people in the room. And the algorithm learns, that's why they call it machine learning, how to connect data to the number of people in a room. To the point that when me and my engineers were building this, we couldn't figure it out, right? It would count. We would set up a test set of 20 people in the room, and our device would count 20 people in the room. We'd be like, fuck, how'd it do it? That's the thing about machine learning. Not only does it make you say fuck a lot, but a lot of times you don't know how it came up with the answers. And what if it came up with 21? Now what? Fix that bug. See what I'm talking about? This is the analytical processes of a software tester are incredibly useful here. But there's a different set of skills too. You have to know how to label data. You have to know how the machine learning algorithms work. You have to understand how one algorithm works as opposed to another algorithm. This is a different set of analytical skills. You cannot divorce your software testing skills from the skills of the underlying platform and algorithms and machines that you're working with. And that counting people in a room is a hard problem. There's multiple data sets that are required to figure it all out. And if you know there's 20 people in the room and the algorithm counts 21 people in the room, find and fix that bug. This is the future. Understanding how this stuff works to a point that your software testing skills all of a sudden mean some. Amazon has a lot of QA roles. Do you think they're going in the wrong direction, given that they're a cloud company? Well, they don't have. I don't remember the last time I found a bug in Amazon.com. I'd be really shocked if they bothered with hiring testers there. My bet is that there's maybe some contractors or even offshore stuff. Amazon better damn well have it. I find bugs in Alexa almost every time I use her. So hopefully they're there, but this isn't manual testing. This is the same thing I was talking about with my counting occupancy in a room.
James, also I liked the question that was asked in chat regarding the security challenges in IoT. So basically, IoT is our future, right? So what do you think will be the main security challenges in IoT, and what will be the security testing approaches that we're supposed to use?
Well, thanks for agreeing with me that it's the future. I have a track record of being right in this, so congratulations. So security at some point gets a little bit easier. That's the good news with IoT, because you have devices communicating with devices. When at Biscuit, we have a device that mounts on the ceiling of your room. It kind of looks like a smoke detector, and then we have devices that go behind your socket, the wall plugs, and they communicate. And it's very difficult to trick one or the other into doing something wrong. I know, because I tried, and I'm pretty good at this stuff, because it's a machine talking to a machine, and IoT removes the weakest link of security, which is people, right? The Russians hacked into Hillary Clinton's campaign computers. No, they didn't. They fooled a human named John Podesta into falling for a phishing attack. And so that's one thing that gives me hope about IoT's future, is that security is actually easier. Machines don't forget passwords. They don't reuse passwords. They don't do stupid things like click on phishing links. And they can communicate very reliably and very securely. So yes, it's going to be a escalation of attacks. Security gets better. Attackers get better. Security, right? But there's a lot of hope there, because this is machines talking to machines without humans in the loop. And so I think that security testing is going to be more like, how can we trick these machines to talk to something else? How can we understand how they work well enough that we can get into that, inject commands into the protocol layer, which is a lot harder class of attacks to pull off. So I actually think IoT is going to be, once it's taken seriously, right? We never fucking take it seriously. Microsoft didn't take security seriously until people breached shit. In the web, we didn't take it seriously, right? We didn't write cross-site. We didn't secure cross-site scripting until we discovered that hackers were exploiting us using cross-site scripting. Right? The attacks always come first. So it's always reactive. We have to get over that. Any other questions that you fancied? Otherwise, I'm just gonna go through here, find the ones that are voted up.
You can pick those with the most likes, right?
Nadella versus Ballmer. That's funny. I wrote about that. Go look at medium.com for me. I wrote about that. Steve and I were friends. I had quarterly one-on-ones with him. I imagine Satya and I are friends. I only had a few one-on-ones with Satya, but I mean, come on, just Satya's killing it, man. And I think the one, Microsoft Teams versus Slack, I decry that at some level of like, God damn it, why can't a small company innovate like crazy? I mean, Microsoft was constantly protecting Outlook by not innovating in anything that would kill email. And then Slack came along, and what did Slack do? Slack killed email. And then Microsoft cloned it with Teams, which I find, I mean, it's perfectly legal. It's fine. They want to build it into the ecosystem because all these people have taken a bet on the Microsoft ecosystem, and Slack didn't work as well there as Microsoft wanted it to. I get it. I totally get it. I think there's a lack of honor in it, but now they're innovating, and I think they're innovating faster than Slack, which I'm happy to see. So kind of a double-edged sword there, but I mean, there's no way you can objectively look at Satya Nadella and say that he's doing many things wrong. He's killing it. Fundamental difference between testing AI and traditional software. This is an important question. AI is trained and not programmed, and that's the fundamental difference, right? You're not trying to find flaws in an algorithm. You're trying to find holes in the data that those algorithms process. Someone should write a book called How to Break AI. It probably won't be me. I got 3 titles in How to Break. I think I'm done with that. But I've tested now, I guess, going on a dozen or so AI algorithms, and I think that occupancy counting story, I think got to the heart of what we do there. It's very different. Your skills work, but none of your algorithms and techniques will. And so you need to apply the things you know about software testing to finding gaps in data and bias in data.
James, I know that you are in a tough schedule, so please let's move to the last question in the chat.
All right, you want to give one? It's nice to meet you too. Sunny in Seattle. Yeah, our summers are awesome. James, why did you leave Microsoft? Oh, come on. Test engineer role. Why new Windows updates are very often. Yeah. Yeah, they didn't hire me to run testing. That's probably why. Hey, Julia, how are you? Read and watch to be able to analyze and test IoT products. So my recommendation for IoT is to build something. I did that with my hot tub. I put my hot tub on the Internet of Things a few years ago. In fact, I'm shopping for a new hot tub now. I don't know if I'm going to do it again, but I want one of those swim spas. I go out and build something. Buy a little Arduino, buy a little Raspberry Pi, and build something. Right, even if it's just making your teddy bear talk or making your toaster, report its toasting data. And I think that there's no substitute for just doing something. And if you don't program, learn. There's really good courses out there on that. It's we're all locked in at home, or at least we are in this country. We're all locked in at home. It's not like we don't have time. So take the time to learn something new. And the more you know about AI and IoT and how those decisions are made and those protocols are used, the more useful you're going to be in the future. And there's no better feeling and there's no better career than one that makes you useful and fulfilled. So peace, everyone.
Thank you.
Thank you.
Thank you, James. It was really impressive speech, and it's really good to see the passionate person on the other side. Thank you very much, James.
See
You're
you.
welcome.
Bye.
See you.
See you. Bye.